Welcome back, everybody. Today we're going to take a quick look at the robust scripting language inside of Unreal known as Blueprints. It's a visual scripting language, so if you're used to working with syntax, the same logic applies, but the interface is going to be very different than what you're used to. The good news is, for those less familiar with coding, it's a great interface to start learning about coding logic because you can't make syntax errors. And the hang up is maybe that you just need to learn a little bit about the language, understand a little bit about the Unreal way of doing things before you get fully committed to it. So let's explain how that works and what you're looking at and step right into it. First, where can we find blueprints? If we want to create a blueprint, this node up here is our access point to everything blueprints inside of the engine. We can do a new empty blueprint class, which will give us this dialog box we've reviewed from the previous framework discussion. We can go convert a selection to a blueprint. So if we have a number of items, we can say convert selection to blueprint class, and it'll allow us to convert those to a blueprint class, and there'll be different ways to go about doing that. We can open the available blueprint classes that we've created, and we can open the level blueprint, which is associated with a specific space that you're building, and that is not extensible to other systems. It's just allowing you to control functionality in this one level. In addition to creating them from up here, we do have an access point to be able to go through the content browser and right-click. We can create blueprints this way. I have one that we're going to reference here in just a second, and the way I created that is just by clicking actor and then saying the name here. And so rather than opening up that one, I'm going to open up the one that we've already had established that I've placed inside the level here. When I double click it, you'll notice that we have a different layout. So unlike the level asset, we're looking at a scriptable blueprint asset. And blueprints come in a few different varieties. And so this is a generic actor blueprint. So we'll see this blueprint down here. There's also widget blueprints, and there's different types of graphs that you'll see, like the material graph will have something over here as well. So what I have is by default a viewport. Just like with the scene viewer, where we have the level has everything to show that the content in the world has been assembled through the outliner. Here, this is going to show through our components list what exists for our specific blueprint actor. So if we have a blueprint actor that has things inside of it, then we'll have the components listed on the left side. I have these nested one inside of the other. So this is a child. If I move the parent, then the cone moves with it. If I move the cone by itself, then it stays, the cube stays put. Now I have a default scene root. If I put the cube on the scene root, I will lose the ability to position the object. You notice that this just has the scale, but no transform. The transform is built into the core object. So the cube, if I want to position it relative to that transform, then I want to make sure that it is a child. So we have our components list here. We have the My Blueprint list, which is going to include your event graphs, with which you can have multiples, functions, macros, variables, and event dispatchers. So as you add things and functionality into the space, they'll be listed here. So these are things that your blueprint knows about and has access to. These are things that your blueprint is and can do. When we come over to the tabs, we have the viewport at the top. We have the constructor script, which is going to allow you to operate functionality that will happen whenever the object is updated in editor or when it is spawned into the world. And then we have our event graph where all of our actual scripting is going to happen, and then we have our details panel over here. I have another panel over here. This is a palette list. You can get that through window palette, and this is just going to be a selectable list of all the functions that you can access inside of blueprints. Just know that that list is useful if you're going to be grabbing a lot of similar or nearby functions, but mostly you're going to want to use the right-click menu to pull up your palette. This is the same list that you have over there to the right. It's just got context sensitivity on. If I turn context sensitivity off, you'll see the list is just as long as the one on the right. With context sensitive on, it's only going to show you functions that are available to your current context. So here, clicking on a blueprint actor, what blueprint actor data can I reference or call from this location? That's what it'll be showing me. All right, to move around the graph, I can use the right click to click and drag. You see my cursor will change to the hand. So if I click and drag, it'll move the system around. I can zoom in with and out with the left mouse wheel. When it gets down to the 1, 1, if you hold on Control and zoom a little bit further, you can get further in. Sometimes that'll be useful for what you want to do, but you can zoom out pretty handily as well. And you can see I have a lot of things already put together for us over here. I want to zoom in here and look at the native structure of blueprints. Blueprints is a visual scripting language, which means that we have to connect visual elements through some sort of wire or input-output system. And Unreal uses this wire system that connects through a click and drag method of linking systems together. So as you consider the the simplicity of it, also consider that it can get quite messy. So we have the ability to move in the environment, but you want to be able to select things. Up at the top here, we have this button called Hide Unrelated. So when I click on this, anything that I have selected will be highlighted. Everything else will be faded out. It'll make it a little bit more readable for different objects, but it also can become a little cumbersome to be able to read the whole system. So just know that toggling it on and off can be helpful in making the thing that you're looking for more readable. You notice this compile icon here. If the compile icon is yellow, that means that there is something that needs to be resolved. If it's red, that means it's already tried to compile and found an error. So when you click compile, you should get a green check mark that'll show you that things are all good. And that asterisk up here tells me I need to save, so I'll just click save. To run most of the script inside of Unreal, you don't need to compile because of the live coding system. However, there are some systems that you're going to want to compile with, especially with interfaces. All right. You'll notice that there's a lot of different colors going on inside of this system. We have red nodes, which represent events. Events kick off things inside of Unreal. So if an event starts, you'll notice that if I zoom into it, it has a little arrow for its icon. That means things go to the right from here. So in Blueprints, consider your logic as flowing from left to right, and it literally does flow along these wires. You can visualize that as we go to run, and we'll show that later. When I go to run and it's something from an event, some events will have details that will flow out of it. Some events have just one item in them. If I have a begin play here, this is just going to launch whenever the player or whenever the character or actor starts in the world, whenever the game starts with that thing or it gets spawned into the world. This is going to fire off and it'll flow down what we call the execution line or exec line. This white diamond or pentagonal shape is going to fire off to the right, and then if it has anything that it's connected to, then that will execute its code. Anything that is backwards from that is not going to care about whether or not the line came down this way or not. It's going to only focus forward from left to right. You notice I have these little white nodes here. If I have a line of code that I connect by clicking and dragging, then this click and drag is going to create a path that is potentially going to be obstructed by something else that would make it hard to read. I can double click on that node or that wire to create a node, and I can do that as many times as I want, and I can reroute that node. It's literally called a reroute node. If I have the line selected, I can add reroute node, and that will give me the node that I can maneuver around and draw information from. And I can even draw multiple potential outcomes if it's a data type rather than an exec line. You notice the exec line, I can only have an exec line going forward go to one thing at a time. This can be triggered by many things, but can only be sent forward to one thing, versus data, which can be pulled from one area to many targets. We have the right-click context menu. I mentioned that. You want to make sure that you have context sensitive on while you're learning Unreal, and if there's something that's missing, maybe that's when you turn context sensitive off, but until you get a real handle on how the Unreal data system works, then I would definitely suggest sticking with context sensitivity. And if you find that you are like me and very interested in having your nodes look clean, then you might want to investigate some of the reroute plugins that are going to allow you to organize and maybe straighten up some of these lines. But also there's some built-in features, like if I hold down Control and click on another node, I can press Q to align the first selected node to the second selected node. Or I can take these ones here, and then I can press Q and it'll line all of them up, so it'll be easier to organize. Makes it a little bit more readable. Something to consider as you get into this. You'll notice that I have these encased in a comment box. So the comment box is created by, I can have a node selected, and then I should be able to, or I guess multiple nodes selected, right click and then create comment from selection, or I can just press the C key while I'm out in the wild. With a comment, I can put objects inside of it, and then once I move the comment box around, the objects inside come with it, as long as they're fully encased inside of that box. I can also color code the comments if I wanted to, and there's different details I could get where I would have like the notes would be able to be viewed from a larger view if I wanted a comment that was maybe describing the type of thing. If I had a very robust graph, I could do it that way. All right, apart from the interface, let's talk about the actual types of nodes that we have here. Events exist as part of a blueprint. There's class defaults these events down here are gonna, if I say on take any damage, then it'll create an event that's bound that says whenever this thing takes damage, go fire this event. We have the ability to create our own custom events. If I say custom event, I can just name it. And then anytime I want to call that event, I can fire, and this will create a function call to an event. You notice that the event itself is red with an arrow, but the call to it has the arrow, but it's blue. This is a callable function. We have callable functions, and we have pure functions. So callable functions are ones that have exec lines. They only operate when an exec line gets to them. They'll do their process at that point. A pure function is something that is referenced by a callable function or another pure function. And basically when this function gets called, it'll reach back into the pure function and grab its information. So you'll notice the lack of exec lines on a pure function. You can create functions that have different behaviors that are callable and pure inside of Unreal. All right, when you start off your blueprint, almost all the actor blueprints are going to start off with a begin play node, a begin overlap node, and an event tick, because those are three of the most common functions that you're going to use. And you can delete these and bring them back later. In fact, the begin play node is so common, they even created a shortcut key. If you just hold down P and left click, it'll get the play node. So on play, you can do that. You'll notice the event play, if I hold down P down here and I try to click again, it should, well, sometimes, it should jump me back up. If I go begin play, it'll jump me back up to that node. So the idea that you have more than one of the same event is a incorrect idea about scripting. Events are singular. Functions are going to be named individually, and there's such a thing as an overload function. Blueprints is a little touchy about that, but inside of Blueprints, you want to think that as an event, as a point of interest on this map of the event graph that you have. So it's a specific thing that can only exist in one space. Inside of coding, you typically do three things. You're going to create something, modify something, or destroy something. So in terms of modifying actors, you have the ability to set the actor location, rotation, 3D scale, or modify the entire transform altogether. In terms of creation, we have things like spawning actors and constructing widgets. So these are UI elements. And then we have the ability to destroy an actor as well. You'll notice over here in My Blueprint tab, I have a number of variables that I've created, and there's a lot of different colors going on here. All of the variables types are color-coded inside of Unreal Blueprints. So if I look here, I have the Boolean, integer, float, string. Here, this is that same function, or that same variable. And then you can see these are the get values for these. This will pull information as a pure. And these are the set values, which will use a callable function to apply a value to those variables. And so you can get those very easily. Once I create that variable over here by clicking the little plus icon, I can pull it off. And then once I let go, I can either get or set the reserve. If I hold down Control and move, I'll get one. If I hold down Alt and move, I should get the other. There we go. So Control for get and Alt for set, as in alternate the value. All right, we have node markers. You'll notice that some of these ones, this says creates new widget. This marker here means that it's on the client side, so it's not going to propagate to the network. The delay node here has this asynchronous value here. So the delay node tells you that the completed execution line will stop here until this node has finished doing its work. There's a number of other nodes that have the asynchronous marker on it, but you want to just look out for these different markers. They mean different things about how they operate, and you want to be mindful of what you're using, because sometimes there's very similar nodes with different contexts of how they could be applied. Inside of Unreal, you have a number of the expected logical operators. Now, I can't go through absolutely all of the blueprint nodes, because there's a myriad of these, and it's thousands. But there is an API that gives you access to all of these things, and you can start to sift through that and organize them. And as you get into a specific domain of intention for your contribution to game development, you'll probably find there's a collection that you become familiar with. And as you do a little research, you'll branch out to find new things. Hopefully these videos will help you to figure out what's most useful for you. But these are your basic comparisons. So these are, is equal to, greater than, less than equal, greater than equal, not equal. We can clamp values, compare values, do a different behavior for a greater than, an equal to, or less than. We have Boolean comparisons. You'll notice these ones have the addition pin here, as well as these addition and multiplication ones. If I wanted to, I could compare multiple elements to those. And if I added too many pins, I can remove the pins by right-clicking on them. I need to have at least 2 if I'm going to do an AND comparison. Same thing for multiplication. I can't multiply one number, but I could multiply multiple numbers together and be able to evaluate those in the same calculation without having to nest sequences of pins. The ability to lerp, pull random integers from streams, random integers without stream, a number of ways that you could address how to handle math. Be mindful that the math operators here have a back-end functionality to them. So try to use the most efficient form of the math that you're applying to. Sometimes there are floating point precision calculations that can be very costly, and you want to be sure not to do those on like a per tick basis unless you're running a specific simulation. Flow control describes the way that we can manage code, how we get in and out of different code options. So it's not always doing the same thing every time. The mother of all flow control is the if statement, and in Unreal, that is the branch. So much so that if I go to the palette and I type if, it'll show me branch, because they are so intrinsically the same that people just type if because they're used to programming and they thought in Unreal, why not give them what they want? The if statement here, the branch is going to be drawing from some condition of evaluation for true or false. So any of these ones are going to evaluate true or false. And when I connect it to that, then when the branch execution line is called, it's going to evaluate that condition, run backwards through it, and determine if it's true, do this code, and if it's false, do this code. If I wanted to disconnect these two, I can right-click and I can break this link, or if I have them, I can click on the pin or the line and Alt left click, and it will remove that line. Sometimes you want to break the pin, sometimes you don't, because sometimes the pin has multiple things. Sometimes you just want to break one line. We have inside of flow control, delay until tick, next frame. These will help you avoid race conditions if there's a potential issue for that. And then retriggerable delays, basically if someone fires this again while it's counting, it'll restart the timer, as opposed to the regular delay where if someone fires the exec line while it's counting, it will ignore that follow-up exec call. Do once, do end times with resets. Flip-flop nodes, very handy. Basically says first time I come through, do A, second time do B, third time A, fourth time B, and it'll flip and flop back and forth between those without you having to create the core logic for it. It's basically just a macro to allow you a shortcut in how to express alternating behavior. For loops with breaks, gates to allow something to happen based off of whether or not it's open, so control logic. And then events can fire in to close or open the gate, preventing other activity from happening. Multi-gates, right? So this is going to fire off multiple things afterwards based off of when it comes in. It'll do these things in a sequence, or it'll pick a specific index of which output to execute. While loops, for each loops for working with arrays. You'll notice that this little array icon over here. We have, going to the variables really quickly, in the details panel, you'll see that the variable is able to be set here manually, in addition to being set through code. If I go to add a new variable, this Boolean says, please compile the blueprint. Once I compile that blueprint, I can then set the value over here. All these have a little capsule for their icon, except for this one right here. I made this one as an array. So any of the variables that I have, I can turn into an array of that type just by coming up to the details panel and then dropping down here, and I can choose array. There's sets and maps, which are a little bit more complex for advanced uses. But if you're looking to use arrays, you can just modify that on any variable type, turn it into array. Just know that if you've already used that variable, it'll take a second to convert it, and you'll probably have to do some rerouting before you can clear all your warnings and errors. But there are ways to operate with arrays. There's a whole collection of array functions for you to manage, edit, append, and read out of them. One of the ways that we can control behavior without relying on tick, some junior developers like to leave things to tick and update functions when they ought not be, is to use the timer event, set timer. So we can set timers by events or functions. What we're going to do is tie this off. We can say a custom event. and I can say a timed event is going to do something, and I can set it to go off after a certain amount of seconds. I can set it to loop for that duration. If I want to operate similar to tick, I can give it a very low loop time, right? So tick is going to probably be something closer to 0.02, but if I went it to 0.1, then that's 5 times more performant than relying on tick. And then we can call pause time and unpause timer for the functions once we've established those timers. We have the ability inside of Unreal to get information from within a larger set. So what I have over here, this is a transform like an actor that I would see inside of the world. If I select this as a location, a rotation, and a scale. So going to the event graph, this is a generic actor transform, but I could just as easily get my cube and say get transform, right? And so if I get the world transform for this, it's going to produce the same type of variable that this is. When I use a break is going to allow me to take any sort of composite information and look at its constituent pieces. So if I say break transform, it's going to show me the location, rotation, and scale, because when I have a transform, that's exactly what it is. It's a compilation, a collection, a 3-vector of 3 vectors that represents these independent value types. And within each of these, I could break, and that gets me to a primitive data type of float, right? And so with this, I can break these apart through a separate node, or if I want to, on the specific node that I'm working with, I can right-click and say split struct, and it will split the things off as if I were breaking the details down, and then I can work with those specifically. Now, this is a pretty common thing to do if you want to say launch a character straight up in the air without affecting their horizontal position. You maintain their XY transform, but then you modify their Z location. This is a way for us to intercept and modify data without having to recast or do math on top of something just to get the same value back out for 2 of the 3 pieces. And if you decide you want to collapse that back down, you can always recombine the struct. You can only recombine it if you don't have something hooked up to the wires. Like I couldn't recombine this one because it's got pieces already in there. All right, let's look up at some functional code. Right over here, I have got this wonky little thing that basically says we're going to delay 2 seconds, and then we're going to spawn. And when I choose spawn, what it spawns is going to be based off of what I selected. That'll change the node name. So if you're looking for this node name, it doesn't exist unless you've created this class and have selected it here. But it's going to try and spawn that actor, and in order to spawn it, it must have a transform location. It will not default to anything. So the transform that you're going to get, we're going to say make transform. And if I left that blank, if I said make transform, you'll notice that it has all the 0, 0 values and then 1, 1, 1 for scale. So that's a quick way to get something to show up at the world center and then move it later. But since we know where we want to put this, we want to consider that I want to get the actor transform for where I am. I want the XY position, and I want to offset the Z value by 150. And then I'm going to use that as the transform, and I'm going to set that as what I'm going to pass in here. And then I'm going to get all actors of class, and I'm going to choose the same class that I am, and that's going to return an array. And then I'm going to evaluate that array. If you follow the exec line here, I'm going to check if the length is greater than 5. And you see how I follow the exec line, and then I can read back what's functionally happening. Sometimes it gets very nested, but the idea is that you're reading from left to right, and as you get to anything that's pulling data from the left, you should be able to backtrack that to see what it is it's showing. If the branch is returning true, meaning that the length is greater than 5, it's going to remove a random item from the get all actors of class. And there's probably some debug that should happen with this, but this is something I threw together in a few minutes. But then we'll take that random actor and we will destroy it. So if there was an item removed, then we'll destroy the actor, or it's going to attempt to remove and destroy the actor. And then here is a version of that same code cleaned up a little bit with straight lines, comments, and reroute nodes to make it more readable as to what's going on. Sometimes it's going to get chaotic regardless. But what does this do? This will start off, I'm going to play this off of our event begin play. So when we begin play, we'll say hello world builder, and then we'll run our code. It'll delay, spawn an actor. If there's too many of them, it'll start to delete it. So I'm going to minimize this for just a second, and then we're going to watch that happen. 1, 2, spawn, 1, 2, spawn. and then as it gets up to 5, it'll make a call about the random items inside of the list, and it'll decide to destroy one of them. Right, and so you can see that functionality working just fine. Not particularly purposeful in this case, but you get to see it running. What's actually very interesting about that is that we can watch that happening in real time. So when I launch this, it's going to actually fire off a pulse from event begin play to this. That'll wait 2 seconds before firing off a pulse down this line. And so I'm going to zoom out just to show you here in my debug list. If I have a specific actor placed in the world, I can choose these from the debug dropdown. Or if an object is spawned in the world, I should be able to see it in this list after it spawns, and we'll see that in a moment too. So when I click play, I'm going to change this to play in selected viewport. So in the background, you can see that firing off the node, and then you also see that I have these other spawned assets in here. So 0, 1, 2, 3, 1, 2, 3, 4. Let's see if I can get to one of the ones before it fires off. May have stalled. So if I get in here, you can see that it's firing the nodes. Kind of hard to catch them in real time, but this might be something that might be a little bit easier to do if I could just pause the code. And here's where there's a fun thing for us, is that we actually have the ability to do debugging. So I can set on this delay node, I can say any of the things that control the exec line, I can add a breakpoint to. So I can do right click, add breakpoint, or toggle the breakpoint by F9. And so that allows me to say that the code will stop when that thing starts to run. So when I go to play the game, let's say I do play an editor, and I go to play, it's immediately going to pause the whole game. You can see that we're going to hang out right here for the delay, and I can start to advance a single frame. And if I go back to the code, advance a single frame, and it's going to keep on waiting until that gets figured out. So this is the delay node, not particularly interesting. Let's throw it over here to the spawn actor. So 1, 2, and then it'll come over here, and then I get these nodes where I can continue the execution. I can step into, I can step to the next, or I can step out of the current observation that I have. So all the debugging you would expect from a typical IDE in your visual system. In addition to that, if I wanted to watch a variable, I can right click on a pin and say watch this value, and it'll show me the value of that pin, or that variable, while I'm observing. If you have 2 screens, this becomes a little bit easier to do, and you can see the precision values jumping very slightly for the local Z. That jumped up when something landed on it. All right, this gives us an idea of how we construct these things. In terms of putting them together, there's a little bit of experience and intuition that you're going to want to lean into. Intuition of what you want it to do, and experience of how Unreal gets to do that. That's just going to come through repetition of doing different projects and looking at tutorials. But I hope the idea of putting code together, seeing something do something functional in a relatively short construction without very many instructions, should be hopefully inspiring. I hope it encourages you to explore the system a little further, to look at what it can do for you and what you can do with it. I hope above all else that you go out and keep building.